Hello students, welcome to the another session. Today we are going to discuss the physics analysis for this NEET test 55 released by NTA. The paper was released around 11:30 and this is still about to cross 1 in the night, and I have solved it perhaps the earliest one tonight because I was not feeling like sleepy, so I thought instead of waking up early in the morning it's better to make it in the night itself. So I have done this, and the paper is not that much difficult. It was one of the easiest paper I can see have solved till now. This is perhaps a 26 test. Straight away I'm solving for this NTA Abhyas. So I can say 21 were easy, 21 were medium also were mostly easy, and 3 were tough. 44 is a very good question. I like the question is not that tough, but it's very good conceptual. 37th question has some flaw. Everything is given. I don't know what they were asking for. I think the answer they have already printed over there, so there's some issue there. Otherwise the paper is quite easy one. It's a paper you should, let's say, score maximum. Here an average a student above average should easily get 140 in physics, at least 140 in physics, and very good score should be 1670, 175 sort of thing. This is a paper you can crack. Okay, plus from today onwards I have tried to incorporate some questions of chemistry that we can solve on the basis of our knowledge of modern physics and thermodynamics. So precisely there were two questions from those topics that I have taken, plus one more question that I should not tell to be in the physics side, but I have solved it. So I would be my motive is to tell you that the physics will not help you in 45 questions. It will even help you in 3-4 questions in your chemistry section. So I'll try to take those chemistry questions also from here on in the physics analysis. So let's start the paper. Hello students, आज रात के भी 12 बज रहे हैं लग तकरीबन, and I'm starting the paper in the night because I was not feeling like to sleep, so I'm utilizing this time preparing the solution for this paper. So let's start. Let's see what is in the question 1. A magnetic needle is kept in a non-uniform magnetic field. It will experience. So you remember, in non-uniform magnetic field it can experience both a force and a torque, while in a uniform field it can only experience a torque, not a force. So I'll go for option A. This is an easy one, straightforward theoretical question that you had. Now the second one, the equivalent resistance between the terminal points P and Q is 4 ohms in the given circuit. Okay, then the value of resistance is, first of all, 1, 2, 3. These will be in parallel. I can directly write it as R by 3. This is in series, that will become 4R by 3, and that R in parallel. So what we'll have, 4R by 3 into R upon 4R by 3 plus R, and that is I'm given as 4. So if I do this, what I will get, I'll get this R factor will get cancelled. This is 3 will also cancel. This would be 4R, and this would be 7 is equal to 4. So R comes out as 7 ohms. So option A. This is also an easy one, not a tough one. That's a simple combination of resistances that you had. Now next one. In a potentiometer experiment, a cell of EMF 1.5 volt connected to secondary circuit, okay, gives a balancing length of 165. If a 5 ohm resistance is connected in parallel to the cell, the balancing length is 150. That's a standard case. You know, okay, small r is capital R, L1 by L2 minus 1. L1 is the length when that R was not inserted, and L2 when it was inserted in or shunted, you generally write. So that is 5. L1 was 165. This is 150 minus 1. So what you have, this is 11 by 10. So 1.1 minus 1, that is 5 into 0.1, that is 0.5 ohm. So again, in direct application based question, not a tough one for you. You should be able to do this. Next. In a series RLC circuit, the root mean square voltage across the resistor and inductor are respectively 400 and 700. If the equation of the applied voltage is this, then the peak voltage across the capacitor is okay. So what we have, this is 500, that is 400. So what we know, I know VR max square, okay, VRMS I should write, RMS is given. So I know in the relation is VR RMS square plus VC RMS minus VL RMS. It could be VL minus VC also. Square is equal to VRMS square of the source. So VRMS of the source is 500. So 500 square is 400 square plus VC RMS minus VL RMS whole square. So that means VSC RMS minus VL RMS whole square will be equal to 500 square minus 400 square, that is 300 square. So that means VC, not max, it is RMS, okay. So VC RMS minus VL RMS I should write mod would be equals to 300. Now this is given as 700, so either it is 1000 or either it is 400. So either it is 1000 or either it is 400. So 1000 cannot be the option as per this. This should 400, but we have was the peak voltage, so not 400. I will take with 400 root 2 because RMS is 400, peak would be 400 root 2. If the option 1000 root 2 was there, I would have picked that also. Okay, because there is nothing given whether it is ahead or behind, current is ahead or behind. Okay, next one. Solenoid has an inductance of this and a resistance of this. If it is connected to a battery, then how long will it take for the current to reach 1/2 of its initial final value? So we know that is T half from the analogy of our nuclear physics, and we say that is equals to tau ln2, and tau you know is equals to L by R. So what we have, L by R ln2. What is L? It is 50 milli 10 to the power minus 3, that is 25 into 10 to the power minus 3. This get cancelled, ln2. So 2 ln2, and ln2 is approximately what you used to write, 0.69. So this is 1.38 seconds. So again, an easy one if you take the analogy of that nuclear physics thing, because the variation is both exponential. Now, the linear charge density on upper half of segment is lambda, lower half is minus lambda. The direction of electric field at center O is. So just remember, at the center O is, take this element here and take a symmetric element here, theta d theta. So if I take those elements, whatever I will have, this positive will have the field here, this negative will have the field here, so their horizontal will get cancelled and it will be along C. So you can directly say the value of the field would be, the direction is along OC. Again, not that tough one for you. Next one. Point charge is surrounded by 8 identical charges at a distance r as shown in figure. How much work is done by the force of electrostatic repulsion when the point charge at the center is moved to infinity? Okay, it is moved to infinity, so simply work done would be W external. You know, W external is Q delta V and W electrostatic would be the negative of that. So first calculate the external work. So Q delta V, final voltage potential is 0, and initial one is, because this is 8, we can write it as 8 kq by r. So what we getting it, minus 8 kq square by r. This is external work is negative, that means potential energy has decreased, so the work done by electrostatic repulsion will be positive, and it would be 8 kq square by r. So you can directly go for option B. So again, that ends in not a tough one. Next, square loop ABCD carrying a current I is placed near and coplanar with a long straight conductor XY carrying current I. Okay, looks like this. What will happen? There is no net force. There will be net force, because what we will say, because if it is carrying current, this side will have more force as compared to CD. BC and AD will cancel out, but you know the AB force will dominate. If current is like this, it will attract. If current is like this, it will repel. Okay, so what we have, for that current to be attractive, it should be like this. This we call it clockwise. So for clockwise there will be attracted, and for anti-clockwise it would be repulsive. So you can directly go for option B, no other choices. Okay, next one. In a cyclotron, if deuteron can gain an energy of this, then proton can gain an energy of. Okay, so the radius remains the same, and we have radius is equal to root 2 mk or root 2 me, what you can write upon QB. So R is going to remain the same for cyclotron. So therefore this energy would be proportional to Q square by M. For deuteron and proton, charge is same, E, so E would be inverse to M. Directly I can make out. So because the proton mass is half of deuteron, that means the energy would be double, that would be equal to 80 mega electronic volts. I can directly go for option D. Now going ahead, this is again the Wien's law. The value of B is given, the temperature of sun having a maximum intensity at 5000 Kelvin. Doing these questions, we have remembered that the temperature of sun is around 6000 Kelvin. I can directly take, but let's say solve by using this formula. So lambda m T is equal to B. So T would be B upon lambda m. B is what we have, 0.3 centimeters. So into 10 to the power minus 2 meters Kelvin. And what we have here is 5000 into 10 to the power minus 10 meters. So do this, this again comes out as 6000 Kelvin only, that we can directly do, but it's better to use the formula given sometimes, and some hypothetical questions also comes. Next, a thermodynamic system is taken through the cycle PQRSP. Okay, the net work done by the system is, so net work done is simply the area under the curve. This is equal to what, this gap is 100 kilopascal. So 100 into 10 to the power 3 plus what we can make out, it is anti-clockwise. Because it is anti-clockwise, work done will be negative. So minus 100 into 10 to the power 3, and this gap is Cc, that is 200 into 10 to the power minus 6. So if I do this, 10 to the power 3, 4, 5, 6 cancelled. This is minus 20 joule. So I won't go for plus 20, I will go for minus 20 joule, option B. Next one. Suppose ideal gas equation follows. Vp cube is constant, initial temperature and volume are T and V respectively. If gas expands to 27V, then its temperature will become. So just derive the relation between T and V. So Vp cube, P what you can write as proportional to, you can write as nRT by V. Cube is constant, so N and R remain same. So basically what you have, T cube by V square is constant. Okay, so what we are coming, T cube is proportional to V square, or T is proportional to V to the power 2 by 3. So now what you have done, you have done it 27 times, so it will become 27 2 to the power 3, that will become 9 times, so it would be 90. So again, not a tough one, simply you have to just use PV equal to nRT and convert it into TV. Now the PV diagram of a cyclic process is as shown in figure. Choose the correct option. Okay, A to B. Just look at the curve, PV curve passing through origin. Let's see whatever happening during A to B. During A to B, P and V both are decreasing. Therefore, delta temperature decreases. Delta U is negative. Work is negative. So Q is negative. So QAB is negative. That is directly. This is the first option, and this is negative. That I am easily getting. Okay. So QAB is negative. That is short. Delta UBC. From B to C, definitely temperature is increasing, so delta U is positive. This is also correct. What is happening? Delta W CAB, wait a minute, CAB, C2A work done is 0, A to B is negative, so that is also negative. So choose the correct statement. So for me all of these are correct, so I'll go for option D, all of these. Okay, so all three were correct, so we will go for D. Next one. A clock which keeps correct time at 20 degrees Celsius is a pendulum rod made of brass. How many seconds will it gain or lose per day when temperature falls to 0 degrees Celsius? So this is a concept that you have learned. So what we say, the time lost or gained per unit per second, that we write as half alpha delta theta. How we write it? Because we know time period is proportional to root L. So delta T by T would be half of delta L by L, and delta L by L is alpha delta theta, so we directly remember this result. Now per day means delta T would be half alpha 18 into 10 to the power minus 6, and delta theta is what, 20, and temperature time for a one day is a 24 hour, and 1 hour has 3600 seconds. So this is going to be the answer. So 9 to, we'll just do this. What we'll have, first of all, let the power be cancelled, 1 2 3. So 10 to the power minus 3, so I write it as 9 into 2 into 2.4 into 0.36. That is the way I write. So this is 18, 2.4 into 0.36, 24 6 are 144, 24 3 are 72, and 14, that is 86. So that is 0.864. 18 4 are 72, 18 6 are what we have. 18 6 is 108, and 7, that is 115. 18 8 are, if I do, that is 180 minus 36, that is 144, and 11 155. So I get 15.552 seconds, or yes, 15.552 seconds. So that comes out as B option. Again, I can do this. Next, a mixture of 250 gram of water, 200 gram ice at 0 degree. Okay, kept in a calorimeter, water equivalent 50, 200 gram of steam at 100 is passed through the mixture. Then the final amount of water in the mixture will be. Okay. First, let me check what it is. 250 plus 50, that is 300 gram water plus 200 gram ice I have at 0 degree. And I have 200 grams steam at 100 degrees. So first of all, I can do this mental calculation. Let's say if it comes at 100 degrees Celsius and water if it becomes. So it has the capacity to lose 200 into 540, which is a huge capacity, 108,000 calories. So let me see if it is able to digest that much. So first of all, it will be 0 to 0, and it will become 500 gram water. Ice will melt. It will require 200 into 80. That is basically 16,000. So it is requiring 16,000. That is going to give, ready to give 108,000. Now if this 500 gram completely I take to 100, it requires amount is 500 into 1 into what I have into 100. That is 5000, 4 zeros, that calorie. So what is the total requirement till now? That is 50 plus 16. That is equal to 66,000 calorie. It was ready to give 108,000 calorie, but it won't give that because that is not needed. So I can cross it out. Now this much is needed. So how much is steam will melt? So let's say it condenses x gram to water plus 200 minus x steam plus this 500 gram water. That is what will I have. So what is the amount of water that need to calculate this x first? So this x would be x into 540 would be equals to 66,000 calories. So x would be 66,000 upon 540. So what I have now, double 600 by 54. If I do this, 54 ones are 54, I will have 12 120, that is 2, and I have something left, 120 108, that is again 120, that is 2, approximately 120 gram. So 500 plus 122, what I will have, 622. But please remember, it is finding water, so this 622 include that 50 gram of water equivalent. So effective water would not be 622, it would be 622 minus 50. So that might be the error you can do because of this calculation. So be aware, you have to subtract that 50, so that would be equal to 572 grams. Okay, next. The linear density of a vibrating string is this. A transverse wave is propagating on the string and is described by this equation. Okay, the tension in the string. So simply what you need to calculate speed, you need to equate the speed from both the formula. We know V is equal to omega by k, and that is also equals to root T by mu. Comparing it, this is omega, k is 1, so 30, that is equal to root T by mu. Mu is 1.3 into 10 to the power minus 4. So T comes out as 900 into 1.3 into 10 to the power minus 4. So this is 13 nines are 117. So this is 1170 into 10 to the power minus 4. So 0.117 or 0.12 Newton. That is what we can go for option A. Next. A body starting from rest with uniform acceleration, if its velocity after n seconds is v, then its displacement in the last 2 seconds is okay. In the last 2 seconds. So first remember, it is started from rest, u equal to 0, and here the speed becomes v. This is at t equal to 0, this is at t equal to n. Now you need to calculate in last 2 seconds, that is from t equal to n minus 2 to this. So I can say for this point p to q, I apply the equation which we write as vt minus half at square. That is what the equation I have. So what I will write, v is v, t is 2 second, delta t basically, minus half a. Now I can write this equation first from here to here. So v is equal to 0 plus a into n. So a is equal to v by n. So v by n into 2 square. So that is what I can write. So what it is, 2v minus, if I do this, this comes out as 2v by n. So what I have now 2v, I take as common, it will become n minus 1 by n. So I'll go for option D. So just simple, not very tough. Next. A ball is projected upwards from the top of the tower with a velocity 50, making an angle 30 with the horizontal. The height of tower is 70. After how many seconds will it strike? So this is your tower. This is the height of 70 meters. Now you throw a ball of 50 at an angle 30 like this. Okay. So for striking the ground, we need to consider only y motion. Let's say this is x and this is y. So by the time it strikes, I know the displacement in y would be equal to minus 70. Uy is 50 sine of 30, which is plus 25, and ay you all know is equal to minus g. You need to find t, and because acceleration is constant, apply the second equation. Minus 70 is equal to 25t plus half into minus g into t square. So g is 10, so you can write it as 25t minus 5t square, that is minus 70. If I do this, 5 common, t square minus 5t minus 14 equal to 0. So what I get, t minus 7 into t plus 2 equal to 0. So only available option is 7 seconds. Minus 2 is not possible. So it would be after 7 seconds, again a regular one for you. Next one. In the figure, the block A has 2 kg mass, block B has 4 kg mass. For what minimum value of A starts slipping over B? Okay, for which A starts slipping. Now first we draw the FBD. Let's say I draw the FBD first for the upper block and here for the lower block. Okay, so this is F. Because it wants to go forward, this F2 will act here, and because it is for going forward, this F1 will also act here, F1 will also act here, and if no slipping takes place, F1 would be static, F2 has to be kinetic, no other choices. And here I can write it as N1. N1 would be equal to MAG, and this N1 reaction will be here plus MBG, that would be equals to N2. Okay, so first of all I can say what is F1 max. F1 max would be equal to mu1 N1. So mu1 is 0.2, N1 would be, the block of A is 220, that is 4 newtons. So I can say the common maximum acceleration would be, because that's only one force is acting, that is equal to F1 upon ma, that is equal to 4 upon what we had, 2 meter per second square. So the maximum acceleration common is 2. So for acceleration of 2 common, what I should write, because F1 will cancel out, I need to write only F minus F2 is equal to total mass 6 into A, which is 2. So what is F2? F2 is mu2, which is 0.4 into N2. N2 you know would be equal to the combined weight from the FBD. Combined weight is 60. That is equals to 12. So F comes out as what? 24 plus 12. That comes out as 36 Newton. So till 36 Newton force, they can move together. After that, they cannot move together. So answer would be 36 Newton. Next one. A parabolic bowl with its bottom at its origin has the shape y equal to x square by 20. Okay. Where x and I are meters. Maximum height to which a small mass can be placed on the bowl without slipping. Okay. So at this question, you just remember, if I draw the tangent like this, the slope in the limiting case should be equal to mu s. So tan theta should be equal to mu s. That is the concept that we typically use. You can draw the FBDs and imagine it is like a placed on incline, and you can get that angle of repose analogy here. So mu s is 1 by 2. So tan theta should be 1 by 2, and to calculate tan theta, you know dy by dx. You know dy by dx. What we have dy by dx? We will have it as 2x by 20, that is x by 10. So x by 10 should be equals to 1 by 2. So it comes out as x equal to 5 meter. That is the value that we will have. So we need to calculate the value of height, that is y. X square, that is 25 by 20, that comes out as 1.25 meters. So again, a regular one if you have done this concept, otherwise you might get fooled by the language and the figure. Next. Which of the following statement is true for collision? Momentum is conserved in elastic collision but not in elastic collision. We know momentum is conserved in all the collision. Okay. Total kinetic energy is conserved in elastic collision but momentum is not conserved. This is also false. Total kinetic energy is not conserved in elastic collision but momentum is conserved. Yes, that is correct. So C option. Total energy and momentum both are conserved in all type of collision. No, it is not conserved. Next, 22nd. So in any type of collision, just remember momentum is always conserved. In the figure shown, if all surfaces are smooth and the two masses are allowed to move, then the center of mass of the system will move. So because all surfaces are smooth, so the only forces acting are in vertical, so it can only move vertical. It cannot go rightwards or the leftwards. It can only go down, because in net force mg will be only there. Normal cannot lift them up. So if the cm has to go, you have done these questions, it can only go downwards. Next one. A child is standing at one end of a long trolley moving at speed v on a smooth horizontal track. If the child starts running toward the other end of the trolley with a speed u, the cm of the system will move with a speed. Okay, so what we have, the trolley speed was v and it starts moving with the speed u. So it has started moving with speed u, and we are given it is smooth. Smooth means there is no external force acting, no horizontal forces acting. So velocity of trolley can change, of child can change, but cm cannot change. Cm will still continue to go with the speed v. So it is a basic question on testing your knowledge of center of mass. Next. A molecule of mass m moving at velocity v elastically impinges on the wall at an angle alpha with the wall. Then the impulsive reaction. So okay, so it angle alpha with the wall. So it is alpha is with the wall. So what I can say, the component which is normal would be v sine alpha. So we can directly say the change would be 2vm v sine alpha, because the y component or the normal component is reversed, not the horizontal one. So directly I can say it is b1. Okay. Next. Because you know it will go like this v cos alpha will remain same. V sin alpha previously was downwards, now it is upwards. Next. A hollow vertical cylinder of radius r, height h, has a smooth internal surface. A small particle is placed in contact with the inner side of the upper rim at a point p. It is given a horizontal speed v0 tangential to the rim. It leaves the lower rim at point q vertically below p. The number of revolutions made by the particle will be. Okay, this is also a very interesting question. So here what we have, just let me draw this first. So it is, let's say, given some velocity v0 from here, and it goes like, and finally it leaves somewhere here. So this is P, this is Q. So for one thing I can say, in vertical there is only mg, because no, this is smooth. So the time it takes to fall this height h, that time I can directly say, because horizontal speed was given, no vertical speed was given, so t was equal to root 2 h by g. Now in that time, that horizontal velocity will remain unchanged, because that is not getting disturbed by anything else. So simply number of rotations that it will make, that will simply depend upon one rotation require 2 pi r by v naught time, so that multiplied by n, that is equal to total time. So the number of rotations would be v naught t by 2 pi r. So what is t? T is root 2 h by g, so I can go for option. Now moving ahead, next question 26, what we have, the acceleration of a body due to attraction of the earth at a distance 2r from the surface of the earth is, okay, so the g will become simply what I can say, g will be, that is equal to gm upon r plus h, which is 2r ka whole square, that is become gm by 9r square. I can write it as g by 9. So this value would be a. Don't write the approximate formula here, because the height is very much greater than, is comparable to the radius basically. Two bodies of m1 and m2 are initially at rest placed infinite distance apart. They are then allowed to move towards each other under mutual gravitational attraction. Their relative velocity when they are r distance apart. Okay, this is again a very standard question. So they were infinite apart. Now this is m1 m2, definitely I know this is v1 and this is going to be v2. So one thing is, you can write momentum will conserved of the cm will remain at rest, m1 v1 is m2 v2, and you write energy conservation, the two equations. Or I can directly say, because no external force is acting, kcm will still remain 0, so the complete gain in kinetic energy would be k dash, so that delta k would be equal to delta k gain would be equal to delta k dash gain, that would be equal to delta ug loss. So I can directly write delta k, initial it was 0, so I can directly write it as half mu v relative square. If you are familiar with the cm frame theory, I am using that, otherwise I have told you the method. If you don't know that, you can do from that also. So what is the loss? Initial is 0, so initial is 0 and final is in negative, so this is the loss. So magnitude I can directly write as gm1 m2 by r. So what we have, mu you know is the reduced mass, that is m1 m2 upon m1 plus m2, and this is v relative, which is basically here v1 plus v2 whole square is equal to gm1 m2 by r. So this get cancelled, v relative directly you can write it as root 2 g m1 plus m2 by r. So what option you are getting? You are getting the option A as correct. Next, a particle moves so that acceleration is a is equal to minus bx, x is the displacement, b is a positive constant, the period of acceleration is, so you know, a equal to minus omega square, x is the standard SHM1, that means omega is root of b, the time period is 2 pi upon omega, that is 2 pi 1 by root b, so which comes out as option B. So again an easy question from SHM, no tough one. The displacement of two identical particles executing SHM are given. For what value of omega the energy of both particles will be same? We have done such question I think before also. Let's try it again. Two identical particles, so half m omega square a square, so what we need, omega 1 square a1 square equal to omega 2 a square a2 square. So omega 1 what we have, 10 square into 4 square, that would be equal to omega square into 5 square. So omega would be, again directly say 10 into 4 by 5, that is 40 by 5. 40 by 5 means 8 unit. Go for option D. Again not a tough one, simple question from SHM. Next one. Cubical block is floating in liquid with half of its volume immersed in the liquid. That clearly means density of block is half the density of the fluid. When the whole system accelerates upwards with the net acceleration of g by 3, the fraction of volume immersed. The fraction of volume immersed doesn't change, it will remain half. Buoyancy will change in the same proportion as the weight. So this is a fact you should remember. Even during the acceleration, the fraction of the volume submerged doesn't changes. So you remember this fact, or you can derive that, but this is a result we generally teach students. We derive them and tell them, remember it. In a capillary tube experiment, a vertical 30 cm long capillary is dipped in water. The water rises up to a height of 10 due to capillary action. If water temperature increases, so if water temperature increases, I know the surface tension will decrease and hence the height will also decrease. So it would be going to be definitely less than 10 centimeter. So just remember this thing. And why surface tension decreases? Because you can simply write, as the temperature increases, surface the tendency of the body to coalesce together or to stick together decreases. You can simply think it like when the money comes, the brothers get separated. Same analogy here, as the temperature increases, the tendency to remain together, to save itself, to have the least surface area, that tendency keeps on decreasing. Okay, so next go on. 32. A square plate is kept in the YZ plane, then according to perpendicular axis theorem. So it is placed in YZ plane, so I can directly write the perpendicular would be Ix would be equal to Iy plus Iz. So again an easy one, just checking what you know about the perpendicular axis theorem. And this is now removed from the class 11 syllabus this year by CBSE. Okay. A shell of mass 20 kg at rest explodes into two fragments whose masses are in the ratio 2:3. The smaller goes with the velocity 6. The kinetic energy of the larger one will be. So because it is in the fraction of 2:3, so let us call it 2m into 6. That should be equal to 3m into v. So that v will come out as 12 by 3, that is 4 meter per second. So its kinetic energy would be half. 3m here means 3m, total is 5m. So if you do the calculation, it is 12 kg. Directly I can make out, and speed is 4. So here it is half 12 into 4 square, that comes out as 6 into 16, that comes out as 96 joules. So go for option A. Next, the electron, the hydrogen atom makes a transition from 3 to 1. So because it is 3 to 1, I can say the energy difference would be 13.6 minus 1.5, that is 12.1 eV. You remember the values. So the recoil momentum of the hydrogen atom, we know the recoil momentum of hydrogen atom would be equal to P of the photon, and photon is E by C. I can write E is 12.1 eV upon C is 3 into 10 to the power 8. So converted 12.1, okay, 12.1 into 1.6 into 10 to the power minus 19 upon 3 into 10 to the power 8. So this is 4 point, what I can say, this is 4.03 approximately. So 4 into 6.4 something, so it would be 6.45 I can make out into 10 to the power minus 27. That is what I'm getting. So I'll go for option A. Okay, next one. When an electron revolves around the nucleus, then the ratio of the magnetic moment to angular momentum, you just simply remember this mu by L gyromagnetic ratio is equal to Q by 2m. So because it is Q by 2m, you know the value would be E by 2m. That's an easy one for you. You all remember this result. This is very important. Next, a radioactive sample at any instant has a disintegration rate 5000 decay per minute. After 5 minutes it becomes 1250. So just checking at the data, I can say it become 1 by 4. So 5 minutes it become 1 by 4. So half life is equals to T half, I can directly say is 2.5 minutes, and T half you know is equal to ln2 by lambda. So lambda would be ln2 is 0.693 upon 2.5. So do the calculation now. What we have point okay, you have to write in terms of ln2, so no need to do that this much of effort. What is it is lambda would be ln2 by T half, so ln2 upon 2.5, well, that is 0.4 ln2. So that's a easy one for you. You can easily make it out. This is option B. Next, when a metallic surface has a threshold 4 lambda is illuminated with light, lambda stopping is V. When it is 2 lambda, it becomes V by 3. Threshold wavelength for the metallic surface is, we are already given threshold wavelength for the metallic surfaces. What we need to calculate now? There is nothing we have to calculate. So there must be some issue. It seems there's some typo here. I'm leaving it because there is nothing to calculate for me. Now 38. If an electron and a photon propagate in the form of waves having the same wavelength, okay, it implies that they have the same magnitude of, okay, having the same wavelength. So lambda is same, so lambda is h by p, that is the de Broglie wavelength relationship will hold for both, so they will have the same magnitude of momentum. Again a very easy one for you. The given logic gate truth table is, just remember what gate it is. You all know this gate is what we call it as the NAND gate or the NAND gate, and NAND gate is 0 only when both are 1, otherwise it is always 1. So otherwise it is always 1, and it is 0 only when both are 1. So both 1 will give us 0. Okay, so what will have, C will be 0 only for one case, and that is for 1 1. So this is option C I can go for. The style is different from the usual truth table that we draw, but you can make it out. In a transistor, emitter is more highly doped than collector. Yes, collector is more highly doped than collector. No, both are equally doped. None of these. So option A. Go ahead. 41st. You know maximum doped is emitter and the least doped is base. A transistor is used as amplifier in common base mode with a load resistance of 5 kilo ohm. Current gain of the amplifier is this, input resistance is this, the voltage gain and the power gain. So simply voltage gain you can write as current gain, which was 0.98 into the output upon input resistance, that I can write as 5 kilo ohm upon, that is 5000 upon 70 I can write. So what I will get, 7 I can write it as 0.14. So 500 into 0.14, that is 14 5s are 70. So voltage gain is 70. That leaves me with one option, so I go for A. Next, a crown glass prism. Just remember this crown glass prism dispersion thing is coming, so if you have not studied, please study it. This was removed from the CBSE syllabuses, but you need to remember it because many questions I have seen in NTA test in NEET examination. A crown glass prism of refracting angle 6 angle degree to be used for deviation without dispersion with a flint glass of angle prism alpha. So what we have, deviation without dispersion. So dispersion has to be stopped. So what we should have, mu v minus mu r into A should be equal to mu v dash minus mu r dash if I write other one as dash 1. Okay, so that A dash is alpha here, so I can write it as A dash here only. So for the crown one, mu v minus mu r. So 1.533 minus 1.53, that is 0.010, okay, into what I have, 6 degree, divided by, here it is 645665, that is 0.020, so this comes out as 3 degree. So again, this is a question you must have done if you have done this thing. Not a tough one for you if you know the theory. If you don't know the theory, then you can't solve, that's a different case. A beam of light consisting of red, green, blue colors incident on isosceles right angle prism. The refractive indexes of the material for the colors are this, the prism will be. So first of all, remember, any light, it will fall normally, and this angle from the common sense will be 45 degree. So what it is falling at, sine 45 degree. So I need to find out the theta c. So if I found out the theta c here, sine theta c is 1 upon 1.39. Here it would be 1 upon 1.43. Here it would be 1 upon 1.47. So I can clearly see this sine theta is greater than sine theta c only for these two. For these two, what will have TIR, and this will pass through. So red will pass through, but green and blue will get TIR. So it will separate red color from green and blue. That is, I can say. So this is also a very general question given in the notes of all institutes, all books. Monochromatic plane wave, speed c, wavelength lambda is diffracted at a small aperture. The diagram illustrates successive wavefronts. After what time will some portion of the wavefront xy reach P? Okay. What time xy will reach P? Okay, so what we have, lambda diffracted as, so simply remember, this is the gap, this is the gap, this is the gap, this is lambda, lambda, lambda. So 3 lambda distance I can directly say, because the wavelengths are separated by the same distance, so gap is 3 lambda. So 3 lambda by c, you can directly say. This is a very good question that might confuse, 3 lambda by c. Okay, so option C. So it's a very good question. I like the question because it's not that easy to interpret it. You need to remember the theory of how you draw the wavefronts typically. Okay, so next, the contrast in the fringes in any interference pattern depends on, the contrast is best when the intensity is same, because minima is 0 and maxima, so you get a black and white contrast type of thing. So it depends on the intensity ratio of the sources. So we say both should be of equal intensity to have the. So this was the physics paper, but to your love, your comments have encouraged me, and now I am telling you, physics helps you solve more than 45 questions in NEET. I am taking few questions of chemistry which I can call them into be my domain or in the domain of the physics. Now see the first one, the question number 30th of the chemistry that I have taken. Calculate the energy in joule corresponding to light of wavelength 45 nanometer. So we have the formula hc by lambda. So we have to do this. Because we have to go in SI unit, 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by lambda 45 into 10 to the power minus 9. So do this power thing. This is a 98817. This is 10 to the power minus 17 into 6.63 into this is 1 by 15. So what I get, 0.4 and again 63, that is 0.44 approx into 10 to the power minus 17. So going by the options, it is clear, it is 4.42 into 10 to the power minus 15. Not minus 15, sorry, if I do the calculation properly, 4.44 into 10 to the power minus 18 joule. Okay, so this is question 30 that you can do. Next one, 31st. This I doubt is in physics domain, but I feel that I can do that, so I am telling it. 1 gram of magnesium is burned with 0.28 gram of oxygen. So I can remember magnesium solid plus O2 gaseous gives MgO. MgO is basically solid, I suppose. Maybe solid I can make out. This is 2 mgo, so this would be something like this. This is, I suppose, how you balance the reactions. So now you have this 1 gram, you have this 0.28 gram. So I can directly say its 2 mole require 1 mole. Its 2 mole means I can say 48 grams is corresponding to, let's say, 32 grams of that. That is the ratio that I have. So from that I can easily make out this is the limiting reactant, so it will vanish, and corresponding to this 0.28, the amount it would be used would be 0.28 into 48 by 32, which I can write as 3 by 2.14, that is 0.42 gram. So it will be left in excess 1 minus 0.42, that is 0.58 gram. So magnesium will remain 0.58 grams that I can do. Okay, next one. For the given isotherms, which of the following is correct for T1, T2, T3? So remembering, if the moles are same, I can directly say draw the line here which crosses it at the least will have the greatest of the temperature, I can directly say. Or the better thing is like this only. At same volume, the one which has the highest pressure has the highest temperature. So that you have done T3 is greater than T2 is greater than T1. Go for option A. So 3 bonus questions for you. So overall the paper seems to be easy for the physics, and these 3 questions also seemed easy to me. So keep sharing, keep subscribing the channel, tell your friends who can benefit from this. Thank you all for watching.